Fantastic elastic.
It's 2 p.m. on a Friday afternoon here in Aotearoa, New Zealand. We're Science in a Van, and we're going live. It's so exciting.
Yeah.
As always, we're in our garage here in Mangere East, the 275. So, welcome.
Welcome. There we go. So we are very excited about today's show. Back in March, when we started doing our live videos, we actually did this experiment that we're about to do as part of one of our shows. And although it's a classic science experiment, it was the first time that we did it. And what happened in that show is we realised there was a lot more. So we're dedicating this show to it. Also, in this show, we're going to keep you up to date with what's happening with our secret Zoom Christmas party, and we'll tell you more about that a bit later on. And in the traditions of Science in a Van Live, we will end with a side-splitting joke of the day, day.
Kia ora, Marina. Thank you for tuning in. So today, we're going to be doing an experiment, as Alan said, and we're actually going to be looking at energy. So what we need to know before we get stuck into the good stuff is a couple of things. Number one, heat is energy.
Heat is energy.
Got it?
Yep, heat is energy. Got it. Yep.
We do get confused. It's okay. And the more energy you have, the more heat there is. Okay, so that's pretty easy. That makes sense, right?
Yeah.
More energy, more heat. Done. The other thing we're going to look at, which I get a bit confused about, but it's going to be fine. We're going to be talking about density.
Ooh.
I know. I've been called dense a few times, but that's not what we're talking about here.
But density is like how hard or how soft something is, though.
Nice.
There we go.
And we're going to be talking about density in relationship to a material. It's very, very common. Water. We're going to keep it simple, people. Don't worry. So we're going to be we're using water to talk about density, and we're going to be looking at hot water and cold water. Okay, that's going to be in our experiment today. And what we need to know about the cold water is it has a higher density. Okay, and the hot water, I'm looking at my notes because I get confused, it's got a lower density.
Right, yeah.
And that is because of the energy, the heat and the energy. The hot water, there's lots of energy, there's lots of heat. So the little molecules and stuff, they're going a bit nuts, right? Yeah. And there's more space between them, and that gives them a lower density.
Yep.
Yes, I got it. And the molecules in the colder water are closer together. So there's a higher density. Don't worry, it will all become clear because we're going to do a great experiment about it.
So in a few moments, I'm going to pour water into these 4 jars here. 2 of the jars I'm going to fill up with cold water, which is going to have a higher density than the hot water.
Yep.
And I'm going to fill up 2 of the jars with hot water as well, which are going to have a lower density compared to the cold water.
Nice.
Now, the thing is I just want to make something clear before I start pouring the water in. We've got blue food colouring for our cold water, and we've got red food colouring for our hot water. So I'm going to do that now.
Excellent. Now, you can totally recreate this. I mean, I'm so lucky. I have a responsible adult in my life somewhere. But the food colouring doesn't, well, I don't know. That's not really part of the experiment, but it helps us to see which ones are cold and which ones are hot, because water, H2O, is transparent, so it's a bit tricky to see. So you might just have one lot of food colouring. Just make one of them a colour. It will totally work. If you have 2 colours, it's kind of cool, but not compulsory for your learning. Hey, lots of people are joining. Thanks for joining us, everybody. Yeah. Lots of people will watch this on the repeat, but it's so nice to have people here when we're doing it live. So welcome.
It's always better with an audience. There we go.
Yeah, everything is better with an audience. Well, not everything. Anyway, Alan, so
now
talk us through.
For the fun part, now we got this far, there is more to this experiment.
Really?
What we need to do is get to the point where we've got a cold water on top of a hot water and a hot water on top of a cold water. And we're going to use some playing cards to divide those. This takes a little bit of a setup. Now,
that's tricky.
When I set this up, I'm going to be playing with jars of hot water. We use jam jars because we know they're able to withstand the temperature of like 90 plus degrees Celsius of water. And that but I'm going to put these gloves on as well. The other thing you'll notice is as I set up, I'm going to put the cold on top of the hot, and I'm going to put the cold on top of the hot and then turn one of the sets over. I don't want people shouting at me halfway through, oh no, you're supposed to put a hot on top of the cold.
That's exactly what I was going to do.
I'm thinking about lots of other stuff as well. Right, okay, so are we ready?
Yeah, I'm just glad you're doing this bit, Alan, because it's not my skill set. So as Alan sets up, so he's going to be putting a playing card in between, right? And we need to start thinking like scientists, right? It's in the name.
Cool.
So we need to start making some predictions. So the question is, Alan's actually, all power to you, Alan. When it's all set up, he's actually going to remove the playing card from in between the jars. So the question is, what's going to happen when Alan does that? And we need to start making some predictions. Now, remember, predictions are just guesses. So, and the cool thing about being a scientist is it doesn't really matter if your guess is like wrong or doesn't turn out. We just have to think about what might happen before we do it. So they're predictions, okay? So to help you make your, whoa, the other one, yeah, I'm excited. I'm fine about it.
Okay. Yep.
The suspense. I'm trying not to put them off, but I did get splashed by some red hot water and I'm excited about it.
Literally red hot water. Yeah.
The science is close, people. So well done, Alan. That's
cool.
Really impressive. So we need to start making some predictions about what's going to happen when Alan pulls out the cards. To help you think about it, some questions is, will the same thing happen to both of these things, or will it be different? Will something happen with the colours? That might be something you might want to think and talk about. The prediction might be, we'll just make a big mess. It is live science, so
yeah.
That is absolutely a reality. I don't want that to happen, but you know, this is the cool thing about doing it live. So, Alan, we're going through the scientific process. We had a question, what's going to happen? We've made some guesses, hopefully. You can put them in the chat if you want. And now we can try it out.
Excellent. So, what have we got here? We've got the blue water on top of the red water. So, yep. We've got the cold water on top of the hot water. We're going to do that one first. We're going to pull the card. And you've made an observation about this. So, that you made a prediction about this. So, now it's time to test it and do our observations. And then we'll do the other one as well. So I just want you to watch.
I'm trying to be a scientist and trying to watch, but I'm a little bit.
Yeah. Oh.
Oh, yeah.
Made a bit of a mess there.
It's all right. It's exciting.
Oh. Yeah. Cool.
Wow. And the other one?
Cool. The problem I'm having is I want to use a material that is waterproof, but it's plasticky and waxy, and the heat's heating it up. So I'm just going to put my glove on so I'm comfortable doing this.
Yeah, I think that's great. I'm sure you can already make some observations about what's happening here. It's pretty exciting. And now the hot water's on top, remember? He's going to take out the card and let's see what happens.
That went a lot smoother.
Yeah, well done.
I'll get my mitts out of the way so you can see what's happened.
Awesome.
By the way, the effect you're seeing has got nothing to do with like sloshing. It's to do with what we're talking about. Just to make that kind of clear, because I messed up, but we had a little shape there.
It's fine. It's fine. So let's make some quick observations. I feel like this is like a purpley colour. Like to you, it kind of might look a bit black. But for me, it's a bit of a purple tinge. And here, like the red is still pretty much on the top. It's kind of going purpley in the middle, to be fair. And just because you might not be able to see it as well as me, there's literally like a whole lot of blue water down at the bottom.
So in science, there's things called variables, and variables are what you can change, or variables that are things that can be different. And a variable here, we've got quite a few variables going on. One variable is we've got hot water and we got cold water. So the temperature of the water or the amount of energy in the water is different. So we've got a variable. Em spoke about the density as well, the blue water having a higher density than the hot water. So that's another variable. But one variable we've changed here is here we had cold water on top of hot water. And here we've got hot water on top of cold water. And that's a variable I want to lock in with you now. So I'm going to say that again. Here we had cold water on top of hot water. And here we've got hot water on top of cold water. So that is a variable that has changed.
I'm so glad we used food colouring because it's kind of like, imagine if we didn't, this would be like, oh, it's just water. So the only difference is the temperature of the water and which way we put the jars of water.
Cool.
Remember, when we heat something up, there's energy amongst the molecules, so it's more spread out, and that material takes up more room, okay?
Right,
And the fancy word for this, as we talked about before, is density. So the cold water has a higher density than the hot water.
Right.
Okay?
Yeah.
So this is less dense, the red stuff, than the blue stuff.
Cool.
Because of the heat, because of the energy.
Yeah. Okay. Cool.
Do you want to talk about your one?
So on this one here, what we had here was we've got hot water on top of cold water. Now, due to the density being different, the hot water can't push the cold water out of the way because the density is so much. So gravity's pulling it down. Gravity's pulling everything down, and gravity is the same all around. But the red water being less dense than the blue water, it can't push out the denser blue water out of the way, so it's not mixing.
Excellent. And this is like the opposite. So, and this one, we had the cold water on top. And we now know, because heat, energy, density, it's all connected, we now know that that cold water had a higher density, right? And the hot water down the bottom had a lower density. And gravity, it's acting the same on everything. But because of that high density being on the top, it gets pulled down into the hot water. So it changed straight away.
Cool. Excellent. So it's incredible to think that purely the temperature of water, so it's the same material, but the temperature of water can make a difference. And how we've set this up with the cold water being on top of the hot water and the hot water being on top of cold water has made a difference. Blows my mind.
I think it's really, I know we're sort of saying the same thing, but it is really cool. Like, it's both water. Like, the only difference is the food colouring, which I don't think really made a difference. It's just so we can see it, but it's the temperature. And now we know from this experiment that the temperature changes the density. And it was much easier for the high density at the top to push through the lower density water and the bottom, just because of the temperature.
And Emily, I don't know if you made this observation, but we had the blue water at the top and the red water at the bottom on this one.
Yeah.
And we know that due to the effect of gravity, it pulled the denser blue water down.
Yes.
And the higher density water pushed the red water out of the way. But you could actually see that because the blue started up here, the red started up here, but when it first mixed, we had a deeper blue purple down here and red at the top. They really switched places, eh?
It was, I mean, I was sort of like keeping an eye on everything because it was very exciting and I didn't want to get it on my new shirt. But yeah, it happened quickly, but there is a difference. And also, I think it'll be interesting to see what happens. We noticed this last time, actually, when we did this experiment. It changes slowly, eh?
Yeah.
And
took a long time.
Like a long time. If you go onto our Facebook page, I'll post some pictures later. And I think on YouTube I can do that as well. So I'll do that. I'll come back in like an hour and then maybe a couple of hours because it does change. And maybe I shouldn't tell you.
Right.
But it does change. Why would that change? Is it going to stay hot forever?
Cool. Okay, so like I say, this is the second time that we've done this experiment. And when we first did it, it kind of was part of a show we was talking about temperature. And we did it for the first time. And when we did it, we used it to explain one thing. But because we did it for the first time, we're like, wow, there's so much more going on here.
So
we wanted to do it again, and we've dedicated this show to it. I've got a feeling we will revisit this. Also, Emily, I think this experiment should be the topic of our January zine. We do a zine each month, and I think this should be the topic of that zine. We explain it. We can be a bit clear on some of the science, and there's a few other things you need to know about how water behaves that makes this even more magical and mind-blowing. What do you reckon?
Brussels sprout.
There we go.
I think that's a great idea. There's so much. Like, we've just touched the surface. It's really, really great. I would love that. Hey, if you want to get your hands on one of our zine being small magazine that we make ourselves, go to our Ko-fi page. So, I'll put some details in the comments or something. But go to our Ko-fi page, find our Science in a Van page, and if you become a subscribing Van fan, we send you one every month. Like, it's really, really cool. And also, open to everybody is our Zoom party on Monday. Ooh. So Monday, 7 p.m. New Zealand time. Remember, New Zealand is in the future in so many ways. So at 7 p.m, we're going to run like a Zoom party. We're going to show you how to do some fun experiment. We're going to have heaps of jokes, obviously, because that's how we roll. And it's going to be really cool. Like, it's just going to be a lovely group of Van fans having a nice time and celebrating the end of 2020. But you do need to get tickets to get the Zoom link. So go to our Ko-fi page and check it out.
Excellent. Before you all run off to our Ko-fi page and get tickets for our secret Zoom Christmas party, I just want to say a few things. With the Zoom Christmas party on Monday and next Friday being Christmas, we are going to have a little bit of a break. But on the 1st of January 2021, at 2 p.m. next year, we are going to be doing another live video. So, heaps coming up. So we've got the Zoom party at 7 p.m. on Monday, the 21st of December. Go and get your tickets from Ko-fi, and then we'll be back with you on the 1st of January at 2 p.m. doing another fantastic live. Emily's just going to put that down there.
I'll just put
but before we start all of that, we have to finish this. And of course, we're going to finish with Joke of the Day.
And because it's nearly Christmas, I love Christmas a lot. And it's totally up our alley. Yeah. We've got Christmas cracker jokes. So pick out one and give it to me.
You go pick it out.
Oh, I'll pick it.
There you go.
We've got a whole bunch of Christmas cracker jokes in here. Oh, this is like a classic. I might have to do more than one. So hold the hat. Because lots of people might know this. Why couldn't the skeleton go to the Christmas party?
This is one of those jokes you can use for lots of different events. Why didn't the skeleton go to the Christmas party?
Come on, you know this one. Do you want to say the answer?
They use it.
He had nobody to go with.
He had nobody to go with.
That's a classic.
Hey, let's do another one. Yeah.
This is another good one, actually. Oh, no, I think we've got that one. Give me another one. Give me another one. I do love my Christmas cracker joke. Oh, this is different. What's round and bad-tempered?
What's round and bad-tempered? An angry Christmas pudding?
A vicious circle.
There you go.
Hey, thanks for watching.
So, my friends, that is our Science in a Van live for today. You are fantastic and awesome. Remember, be like a proton, stay positive. Catch you next time.
Bye, everybody.